So in today's session, we'll be seeing about linear algebra for machine learning. So these are the specific topics from the linear algebra. This is a particular branch of mathematics where we talk more about matrices. So we are going to cover these different concepts. Okay, but before going into these deeper concepts, I will just give a motivation. Like we see how these linear algebra concepts are used in machine learning. Like yesterday in the previous session, we have seen when we have a data, how we are converting that data, how we are using that data into a matrix form and then into your ML, right? How you are bringing it, the linking I am going to explain you. But these topics of linear algebra, which we are having in our course, are almost all very much familiar to all of you. Maybe in next session, after this session, we will have matrix decomposition, which is very important because we are going to use in matrix decomposition, we are going to use all these concepts. So quickly, we'll go through these particular concepts. Let's take an example and try to understand, right? See, I'm talking about a machine learning problem. Given wind speed, I want to predict what is the power output. If you have a windmill like this, a turbine, a windmill like this here in this diagram, if you see, right, based on the wind speed, if the wind speed is more, that particular fan rotates faster and it generates more output, right? So I will see this is a small, simple SLE machine learning problem. What is the problem? Given wind speed, I have to predict what will be the output. So you have historical data set with you. What is the data all about? It has when the wind speed was 10, what is the power output? When the wind speed was 20, what is the power output? Or when the wind speed was 13.3, what is the power output? So I have a data with me. I want to predict. Given a particular wind speed, I want you to predict what could be the output, power output in kilowatts, what will be the output. So this can be seen as a simple ML problem. So I think you can simply say, can you tell me which machine learning technique can we use to find out this? Yesterday we have seen many algorithms in simple, silly terms, right? Given wind speed, what could be the power output? So I'm doing prediction kind of a thing. I would say this is a simple linear regression problem. Okay, linear regression problem, right? So again, I have taken a simple example. I'm trying to bring with this example, I am trying to bring you into linear algebra. So I have a machine learning problem. What is that problem? It can be a general problem though. I have given wind speed, I have to predict, I have to find out what could be the power output. How can I do this? You have the data set we talk, then we say machine learning problem. Am I not audible? Somebody please confirm. Am I audible? Okay, right. So that is my problem. So simple SLE question, given the wind speed, find out what could be the power output. Now, if I have the data with me, if I plot it here, if you see, I am having problem is simple. You are given wind speed, you have to predict what will be the power output. So that is my input, wind speed in this meters per second, and then output will be in kilowatt. Okay, so if I have the data, if I try to plot, I have the historical data with me. That is my machine learning data. The data I'm trying to plot it here. When I plot it, you see when the wind speed is this much, so power generated is very less. If you see these dots, these points indicate that the relation between the wind speed and the power output, right? So if you see, for example, if maybe you can take this one, if wind speed is around some 6.5, so the power generated is around 2200 or something, a rough estimate I'm telling you, right? So this way you can represent as a graph, single graph, or can I say this is equal to mx plus c, line equation, simple line equation format. Okay, don't go into this mathematics, focus on this. You have one input, you are trying to predict the output, right? Now I can do this. This is a machine learning problem for me. But what if, so that way you can find it out. If you see, I can form an equation mx plus b equal to y. I want to find out the y value. Given the wind speed, I have to find out the y value. How do you find out this? Generally in mathematics also we do. How do we generally do this? When you have an equation y equal to mx plus c or b, if we call, our target is to find out the value of m and the value of b. Our target is to find out the value of m and b. Then only we can form a machine learning model. So this can be my model. Mx plus b can be my machine learning model. So you have the data set with you. What do you have? You have different x values and you have different y values. Form an equation. That equation can be something like this. Maybe I have, by seeing this, I would say around 5, not 5x minus 10.3, something like this. Rough example I'm giving. So when you, this is one ML equation. How did I form this? Using regression analysis. I'm not telling you how to calculate, just assume. Using regression analysis, I found out this equation. It means I had the historical data, I applied my regression machine learning algorithm, I got this model. This can help me in predicting, given any input, it can give me the output. What is the input? Input is your wind speed and output is your power generated. Okay, simple ML problem, kind of a regression problem. Now, slowly let us increase the complexity of this. Assume in the previous case, we were discussing about given wind speed, I was finding out the power output, how much power I was generated. But there is one more parameter which is dependent for this power output generation, that is temperature. Okay, so the power output is not dependent directly on the input. It is also dependent on the another input called temperature. So given the values of wind speed plus temperature, I can find out what is the power generated. Okay, because this is not a direct parameter, only the wind speed cannot tell you how much power. Assume this is the case. So if I represent them as an equation, you can see y equal to w1 x1 plus w2 x2 plus b. What is this w1, w2, b, which we have to find it out. So this becomes your multiple linear regression. Where your output is dependent on multiple input variables, not on a single variable. If it is dependent on a single variable, we have a separate session on regression, don't worry. But this again, I'm little going into regression analysis so that you can understand how easily how linear algebra is required for this machine learning. So you give to find out the output is dependent on two different input variables. One is wind speed, other is temperature. Let the wind speed be x1, temperature be x2, and let this be y. Okay, so you can ask me, sir, why is a b here? B generally stands for bias, means some error rate, error variable. It can just an error parameter. Sometimes your model is not exactly, so we add a small error of 0.05 kind of a thing. Okay, now don't see this is a regression problem. So you now this is clear. You got an equation like this. So what is your problem here? You are having the wind speeds, temperatures, and power output of last 1 year. Okay, historical data you have with you. You form a machine learning model which will help me in given any wind speed and temperature. It should predict. It should do prediction and tell me what could be the power output generation. Suppose tomorrow morning at 10 a.m. I say this is the wind speed and this is the temperature. Can you find out what is the power output? What is the power being generated? Like this, we have prediction problem. Correct? One input, one output. Multiple input, one output. We have. Now suppose assume there are multiple features. Okay, like wind speed, temperature, pressure, humidity. All these parameters play a role in finding out what is the power output. You can take that case. Okay, now see, now if you represent this, again, I have multiple inputs and one output. It means to get this power output, it is dependent on multiple input parameters. Correct? This is also possible, right? To make my regression model much better, to make my machine learning model much better, I have to design a best model. To define a best model, I should study which all parameters are creating impact on the power output. Only wind speed we thought we can form directly, or if temperature also is there, pressure, humidity, like this, there can be n number of features. There can be n number of features which are creating an impact in producing this power output. Okay, again there is a little one point to just interrupt in between. In statistics we have a reverse engineering process. What we do, given suppose like this, we have 10 features. 10 features are given, the data is given and the output is given to us. Okay, so f1, f2, so on, f10 is there and the output is there, right? So you have data with you, 1, 3.5 something, some data you have with you and the data is there. You form a model with this. You form a machine learning model, assume regression model you are forming. Your equation is something like this: y equal to some 3f1 minus 2f2 plus 3f3 and so on plus 8f10, something like this. You got a model, right? But the accuracy of this model is not predicting properly. So in statistics, that is, I'm just reminding you, in statistics we have some metrics which will help us to identify among this f1, f2, f3, f10, which are very important features, which are contributing more to this output for power generation. Why are we wasting our time calculating big values, f1, f2? Maybe out of this 10, f1, f2, f5, f7 and f8 are sufficient to tell the power output. Okay, so this is also we are going to study in statistics part. So for now here our goal, so if I represent them as an equation, see like this. Can I make an equation like this? You saw the first equation, mx plus b, 1. Second case also you have seen that w1 x1 plus w2 x2 plus b, because there were two parameters. X1 is your wind speed, x2 is your temperature. But now if there are n number of features dependent for generating a particular output, so can I write like this: w1 feature 1, w2 that is feature 1, w2 f2, w3 f3, w4 f4 plus b equal to output, assuming there are 4 features. Okay, assuming there are 4 features. Our goal is to find out these values of w1, w2 and b. If you can find out these values, you form a regression model. You are indirectly a machine learning model. The model will help you, given the temperature, humidity, pressure and wind speed, it will tell you how much power will be generated. So we are forming a prediction model. Okay, so the prediction model is dependent on the power generation is dependent on 4 different features. So we form an equation like this: y equal to w1x1 plus w2x2, w3x3 plus w4x4 plus b, a constant, right? So this is what we do. Now if I say this is for one data set, right? This is for one data set, in the sense I will take an example. So given wind speed, temperature, pressure, humidity and power output, somebody has already given me a data set to me. Wind speed, I'll just write 2, 3, 5, 6. Temperature 38, 42, 16 someday and 27 someday. Okay, pressure may be some 100, 150, 120, 96. And I have humidity 32, 34, 35, 30, 29, something like this. So this is a data set given to me, right? Using this power output also 1500, assume some values here. So somebody has already given me an existing data set to me. Now this, using this data set, I have to form one single line. I have to form one single line, that one single equation, something like this: y equal to some 10x minus 2y x1 2x2 sorry plus 3x3 plus 4x4 minus 0.75, something like this. So this is my machine learning model. Okay, this is my model. Now this model will help me in doing predictions. Given any wind speed, temperature, pressure, humidity, I can find out what is the power generation. Correct? So I am representing into an equation form. See, this is my target. I want to find out this. Okay. So now So this is what I was saying about W1 x1, W2 x2, W2 xn, B equal to Y. This is what I have to find out. This is about one data, but my data set is not single, no. I have huge data set. Assume I have 10 rows of data set. I have 10 rows of data with me. In such case, I will have 10 such equations. W1 x1, W2 x2, this is just features, no. Assume there are only 4 features, F1, F2, F3. So this will be x4. This will be x4. This way. So when you have 10 rows of data, you will have 10 such equations. If you solve these 10 such equations, you can find out the values of W1s. You can find out the value of W1, W2, W3, W4, and B. When you can find out these values of W1, W2, W4, and B, then you can get one single equation. You can get one single equation. Again, I'll repeat quickly here what I'm trying to do. If I have one data set, if I have only one record of information with me, I am forming this one equation. W1 x1, W2 x2, W3 W4 plus B equal to Y. But my data set contains 10 records. So I will have 10 such equations. Okay. What is known in this? X1, X2 values are known, and Y values are known to us. Our target is to find out the values of W1, W2, W3, and W4 and B. If I can find out these 5 values, you see W1 is common here. W1 is same in everything. So I have to find out only one W1, one W2, 3, 4, and B. Okay. So if I find out the values of W1 to W4 and B, I can write one generic equation using W1 x1 plus W2 x2 so on. Maybe in numerical form if I write something like this: 10x1 minus 4x2 plus 3x3 minus 8.4 x4 plus 0.72, something like this. This is my machine learning model. Okay. Now again I will go back and repeat. Before I come to this point, I said we are having a problem, general problem. Given wind speed, temperature, pressure, humidity, you have to do a prediction. You are having a machine learning problem with you. The problem is to predict how much power will be generated by the windmills, turbines, that wind turbines, whatever we have, given these 4 inputs. It's an ML problem. I converted them into equations. By solving these equations, I am trying to form a ML model. True, but something like this. Is it not? See, this x1 represents wind speed, x2 represents temperature, x3 is pressure, x4 is humidity, and there can be n number of features. If there are n number of features contributing towards power output, I will have n number of. Then I have the output with me. Okay, so this is how we represent the equation. But the observation here is that the weight values, the W1, W2 values are fixed, common, which is what we have to find out. That problem is called regression problem. Identifying the values of W1, W2. How do I identify those values? As a mathematician, if you can solve these 4 equations, you can form a regression model. How? By solving this, I'll come to know the values of W1, W2, W3. But how do we solve these kind of equations? When you have such equations, how do you solve them? Maybe I will talk a simple silly example. Somebody says x1 plus x2 equal to 7 and x1 minus 2x2 equal to 3. For example, right? This case, can we find out the value of x1 and x2? Maybe some rough value we can find out. How can I solve this? Just add. So this becomes 2x1. Maybe something I will write simpler one. Yes, let's make it 7 and 8. Okay, x1 plus x2 equals 7 minus x1 plus 2x2 equal to 8. 2 equations I have. If I just add them, it becomes 3x2 equal to 15. x2 is 5. Then x1 becomes 2. So I get values x1 and x2. 2 simple equations. Fine. But is my machine learning data a smaller one? No. ML data is huge. I have hundreds of records, hundreds of features, right? So the base of linear algebra comes here. given a machine learning data set, okay, having n number of rows and n number of features. The target is to form a machine learning model called as regression model. How do you form it? You can form it using the concept of matrices from linear algebra. Let's see, how do I convert these equations, this set of equations? How did I get this equation? From the machine learning data. The ML data, whatever I had, that only I have just converted here. I have wrote them into equation form. Okay, where W1, W2 are unknown, which is my target to find out. So see, I can write them like this. Those W1s I can form a vector, those features can form a matrix. This is your actual data set. This is your actual data set. And this is the output value. This is the output value, output vector. Okay, so you are given this and you are given this, you have to find out the value of B and you have to find the value of W. So those equations I'm trying to convert them into matrix, vector matrix form, vector matrix representation. How did I get this? I got this from a machine learning data. I have an ML data with me. That ML data I have converted into like this. These are all the feature values. If I take a small simple example to understand this better, maybe here. So I have student marks, something like this, subject 1, subject 2, subject 3, subject 4, his placement status. Okay, so here I have 97 student number ones, serial number or roll number 1, 2, 3, something like this, 83, 74, I so on. I have marks. I have student marks. I have their placement status, placed or not placed, 1 or 0, something like this. Okay, so when I have this data, I can, using this data, I form these equations. These equations I am representing as a matrix vector form. Okay, so if you can use regression, if you can form a regression model which will help you in doing prediction. Okay, so those equations are converted into matrix vector form. Now our target was to solve those equations. That's what we are going to learn today. How do we solve those equations? How do you form regression model? Okay, how do you form that regression model? By solving those n number of equations or 100 number of equations. Suppose your data set is having data set is a CSV file of 28 cross 15, means I have 28 rows of data with me and each row has 15 features. I am trying to build a regression model on top of it. Okay, so you have a vector matrix form. Now, little aside, this introduction, if I put it aside, let's see the system of these are called system of linear equations. System of linear, why it's called system of, this is a linear equation, it's a linear equation. Y equal to mx plus b, it's a linear equation. When we call it as a linear, why it is called as a linear, if you see here, see, this is a linear equation. Okay, single line, so linear, right?
Okay.
So this we understood that an ML data set, ML problem of doing a prediction can be converted to a system of linear equations. How I converted it? I converted it using data set. Somebody is talking. Yeah. So I converted that into a system of linear equations. I have to solve this system of linear equations. Little aside from this, let us see some different different concepts. We will put this system of linear equations aside. We'll see this part. System of sentences, I will try to derive you. I will tell you, explain you what is system of linear equations. System of linear equations. How am I getting this linear equation? From the ML data. The ML input, whatever I have, to find out the prediction of the power output. See here, assume there is one system of sentences. These two sentences you see, the dog is black, the cat is orange. Okay, so this is one system. System 2, dog is black, the dog is black. System 3, if you see, we have dog is black, dog is white. Let's try to analyze these sentences. This is very important. Just to understand, maybe this is an easy, you know, lot of information about linear equations, but still, see, this dog is black, okay, cat is orange, fine. Statements are clear, so they can be considered as complete sentences. But here, if you see, the dog is black, the dog is black. Same thing is given 2 times, so redundant information. Information is given nicely here, clear information, complete information. Here, the information is redundant, it is repeated. But here, if you see, we are saying dog is black, okay, it's also white. Is it? It is not possible. It is not possible because contradictory. Either it can be white or black, but not both. But here I am telling it is both black and white, right? So it is contradictory, right? So statements which are redundant and contradictory are called singular statements. Statements which are contradictory and redundant means repetition, they are called as singular. Statements which are complete, clearly given the information, they are called non-singular. Okay, simple idea. If statements are very clear and different, it is non-singular. If they are repeating or contradictory, then they are singular. We need to understand these terms. That's why I'm giving simple example. Let's see another example here. Okay, see, dog is black, cat is orange, bird is red. 3 different entities clearly given, nothing, no problem. They have given 3 statements. System of sentences means 3 different statements which are true and valid. So they are complete. Okay, if you see here, dog is black, again black and red. So 2 times it is given. So it is redundant statements are there. Here 3 times redundant statements are there. Repetition. Here you see black and white both. So contradictory is there. Okay, so when you are given some certain sentences, you try to identify whether those set of sentences are singular sentences or non-singular sentences. If the system of sentences are repeated and contradictory, we say they are singular statements. Otherwise, they are non-singular. Quickly now, I will transform this into equations. Okay, small exercise here. Given, I think this is a simple, silly example. Let's not waste our time in this. Now, let's convert those sentences to equations. Okay, so generally, equations will always have a numerical value. Equations will always have a numerical value. See, between the dog and the cat, one is black. This is a sentence, system of sentences. But system sentences with numbers, you see, the price of apple plus banana is 10. So I can convert that into equation form like this. A plus B equal to A represent price of apple, B represent price of banana is equal to 10. So the English sentence, right? So sentences with numbers are called equations. Sentences with numbers are called equations. Similar way, if you see, this is an example. Now you see, you are given some system of equations. A plus B is 10, A plus 2B is 12. Okay, if you try to solve this, what is the value of A and B? Just by substitution, you can tell this. Substitution method helps us to find out. So A plus B 10. Again, if you are feeling demotivated, why are we studying this system of equations? We have a ML data with us. That ML data we are converting into system of linear equations. We have to solve those system of linear equations. Okay, so we are trying to slowly get into the process of solving those system of linear equations which are in the form wx plus b equal to y form. I'll just erase this. Plus b. This is my system of linear equations. Wx plus b equal to y. Okay, x is the features, w and b I have to find out, and y is the predicted output. Okay, so to solve this only we are learning what are system of linear equations. So English sentences being converted to system of equations, right? So like this, the cost of apple plus banana is 10, cost of 1 apple plus 2 banana is 12. If I solve this, if I can solve this by substituting, you can do this. You will find out that apple is 8, banana is 2. Nice solution. It is very clear. You see, you take the second example here. We are having sum of apple plus banana is 10, 2 apple plus 2 banana is 20. Right. So if I solve this, still I get an equation like this, a plus b equal 10 only. So what are the possible values of a and b to be 10? Infinite number of values. I can have any value. I can put here 8, 2, 7, 3, 6, 4, any number of values I can include here. So we have infinite number of solutions. Okay. So next, third one you see, a plus b is 10, 2a plus 2b is 24. This is contradicting. If I just divide this second equation by 2, I get something like this. A plus b is 10 and a plus b is 12. So how can this be true? Not possible. This cannot be true. So it has no solution. This is contradictory. So if you observe, it is contradictory statement. This is redundant statement. Why? If I divide it by 2, again becomes a plus b equal to 10. 2 times same equation. I cannot find out the solution. So these are singular. Whereas this, we are having a unique solution, it is non-singular. Okay. Our target is to solve system of linear equations. Why do I have to solve them? If I can solve those system of linear equations, I can find out the values of w vector and b, right? I can find out these values, w vector and b, so that I can form a regression model. I can form a regression model. Why do I need a regression model? Regression is the fundamental and very important basic machine learning algorithm model. Regression model can help me in doing predictions. Yesterday we have seen we can use the regression model. For which example we have seen? You are saving money. You are saving your money to purchase bike. Okay. So you given the amount of the bike, you have to tell me how many months do I have to save so that I can purchase the bike. A regression problem. Same thing. So we have multiple equations for that. More deeper if we go, here in this case I have only 2 variables, 2 features and 2 equations. Data set is very small here, right? But if I increase the complexity, if my data set contains 3 features and 3 records, it becomes something like this. 3 features and 3 records like this. Okay, so I have 3 features, 3 records. How can we solve this? Again, by using substitution method, we can do it. I can do this, I can solve this using substitution, this using substitution. I can say whether it has infinite solutions, no solutions, or multiple. So possible thing can be, there can be infinite solution, or there can be unique solution, or there can be no solution, right? It means the regression model which I am forming, the target is again regression. I will again keep linking it frequently. You see, system of linear equations. This is my data set. From the data set, I form this equation. But how do we solve? How do we solve such lengthy system of linear equations like this? This way. If I have this m value, suppose 100, and this n value, suppose 50, it means I have total 100 records of data with me. Each record is having 50 features. I have to solve. Why? If I can solve this using existing data, I can form a machine learning regression model, which will be helpful for me in prediction. Okay. So we understood why we need to study about linear algebra, because we are converting that into matrix form. I'm yet to touch matrices. Yes, I was here. So from this you can see that when the data set is limited, only three rows, and with each one having 3 features, I can solve this manually. I can solve this. I can tell whether what are the values of this A, B, and C, right? So one way of solving this is converting these equations to matrices. That's the easy one. When your system of equations are increasing in dimension, like when you have hundreds of records, it is difficult to say for you, digest for you, that hundreds of records in a matrix is big one. Again, becomes a big matrix. But for understanding, if there are hundreds of records in a data set, and if there are 15, 20, 30, 40 features, how do I solve them to form a better regression model? Right? So before we go, why are we, this is system of sentences. This is system of equations. But why am I using the word system of linear equations? Why are we saying system of linear equations? Linear equations something like this, non-linear are these. Linear means without any powers here. This is just an example which talks about linear and non-linear equations. So all these are non-linear ones. 2 power a, 3 power b, sine a square, b square. No. So our data set is not in this form. Our machine learning data set is cannot be represented in non-linear equation form. We can represent only in linear equation form. Our data set is simply like this. No, you have the student roll number 0012, 0013, 0014. You have subject 1, subject 2, subject 3 marks. So you have some marks here, and you have his placement status. So you can tell what is the placement status. So data is very simple, and they are in a single normal scalar values. Okay, so that's why we call this set of equations as system of linear equations. System of linear equations. Okay, quickly recall from ML data to system of linear equations. You have your data set with you. That data set, for example, we have taken how do you find out the power output generated by the windmills. But the output generation depends on multiple factors. Those factors are called features. So I have one row with me saying that if when the wind speed x1, temperature x2, pressure x3, and humidity x4. When I have these four values, power output is your y. Okay, but my data, I have historical data with me. Using that historical data, previous year data, previous month data, or whatever, some certain time data I have with me. That data, given that data to me, I have to form a equation. I have to form an equation. That equation can be used for me in doing prediction task. So prediction is one major property or a feature of machine learning. We do it using regression analysis. We do it using regression. So what is regression? Having n number of equations formed from the given data set. If you can solve those data sets, if you can solve those equations and find out the values of the constants w and b, then you can say you formed a prediction model. Okay, so our task is to solve this system of linear equations. How do I solve this? If I can find out the values of a, b, and c, with this a, b, c, I can form a model. If I can solve this, I can say maybe a simple one more contradicting statement I want to tell here. See, these three statements, if I solve, maybe this does not suit well, these are not accurate ones, but if I say these three equations, if I can solve and form something like this, 3.5a minus 2.1b plus 4c equal to 13, if I say, or equal to y, I will say, y. So this equation represents these three values, these three equations. Okay, this is generalized one. You give value of a as 1, b, c as 1, 1, 1, you can get the answer as 10. Simple example I'm telling. So you give any values of a, b, c, you can get a value of y. So we are able to predict, you are doing prediction here, right? So from data set, converting that data set, but regression, why this is very less used? It is used, but little less. Regression is applicable for data set of smaller size. True, because I cannot form equations. No, if I have huge data, I cannot have a very lengthy equation. I cannot solve those lengthy equations. So you can use regression analysis for doing prediction given the data sets of smaller size. Okay, right. So how do we convert into matrix form? How do we convert? Any doubt till now? If you have any questions, any queries before we go into, I hope you got enough idea how we are trying to convert that ML data into system of linear equations, which in turn can be converted into matrix. And if we are bringing the concept of linear algebra, we know how to play with the matrices. We will learn those simple operations what we have been learning since our schooling. Using those, we'll try to solve these equations easily. So one way how linear regression model is constructed internally by the Python libraries, it is using this concept of solving matrices. Okay, anything you have specifically, you can post in chat box. Any doubt? How do we convert that ML data to system of linear equations? No doubt? Okay. Assuming you have no doubt now, I know it is little difficult for you to bring into mathematics completely, because you are sometimes feeling all this is what I have studied before, right? So, but that is not simple. That ML data is being converted. ML data is being converted into linear equation. That's why I said, when you are forming a regression equation, you can use regression analysis when the data set size is small. Only then you can use these techniques. But there is one more very, very big application of these matrices, that is in neural networks. We'll see that. I'll just little highlight about one point here. See, why have we used this, the words W1, W2? We have used W because in we call them as weights, and this B is called as bias. Okay, weights in ML terms, we say these are all called as weight. Something multiplied with a feature is called as a weight. Okay, so these are all weights, and this is bias. Okay, that's why we have used the terminology W and B. Whether you use W or not, doesn't matter. Your ML model is used for prediction. You can do prediction giving the values of x1, x2, x3, forming a regression equation. Using that equation, you can do prediction. Right. Now, see, how do we convert it into matrix? I have two system of linear equations. I have two system of linear equations. I am representing this matrix. The constant before this A, that is 1, 1, 1 and 2. I think you all know how we convert this into a matrix. So this way, right? So if it is a non-singular matrix, you have unique solution. If it's a singular matrix, you have infinite number of solutions. This already we have seen different examples, right? So we are having matrix. Now this matrix, if you can solve, if you can find out the values of A and B, you form a regression equation. This regression equation can be used for prediction. True? Let's see. So linear dependency between rows. This is one more simple concept. Dependency, linear dependent or independent. Are the rows dependent or independent? You see the second example first. See, if I convert that to matrix form here, 1, 1, 1, 1, I have a matrix is like this, 1, 1, 2, 2. I have a matrix like this, right? So multiple definitions I will talk here. If you find out determinant of this matrix, AD minus BC, if you do, if that is 0, then it is called singular. Then they are linearly dependent elements. This system of linear equations are dependent on each other. Okay, you can see here, multiplication of 1 itself is second row. If I multiply the first row, first equation into 2, I get second equation. Okay, so second row is the multiple of first row, right? So rows are linearly dependent on each other. This is not formed independently. It is formed by the first row. Whereas this case, it is not same. They are different. So we say system of linear equations are dependent, independent. When if they are common multiples, we say they are dependent and independent. Here you see, I can form the second equation by using first equation. It means if I say E1 equation and E2 equal to 2 into E1, so they are dependent on each other. Whereas here I cannot represent E1 with any value of any constant. I cannot write E2 equal to K E1. Okay, that is not true. I cannot find out the value of K. Right. But there are multiple other definitions also. We have to study about determinant first. We have to study about determinant. So other way also is there. I will continue this dependency part there also. But for now, if I can represent the one equation system of linear equation, equation 1, equation 2, equation 3 I have. If I can represent equation 3 as sum of two other equations, they are dependent on each other. Okay. Other way, determinant, you find out determinant. If determinant is 0, AD minus BC, if it is 0, then they are dependent. That we'll see when we study about determinant. Okay. So another example, that's what I'm talking about. If you can express row 3, equation 3 as sum of equation 1 and 2, then they are also linearly dependent. Right? Same thing, different examples. See, when you have something like this, I have 3 equations here, but I cannot represent any equation in any different form. I cannot do that. Right? But how do you find it out? It's a complex task. This is okay, maybe by doing some small calculations. Okay, if I give 4 equations, 4 parameters and 4 equations, or 10 parameters and 10 equations, how can you find the dependency, whether they are dependent or not? Again, you have to come to matrix. We have to apply matrix operations, what we have been studying. That we'll see in today's session. How do you solve the matrix equations? Again, this is some problem. Let's not waste our time. Given some set of linear equations, converted those equations into matrix form, trying to find out whether they are dependent or not. Okay. You can solve it, but this is simple one. Let's not waste our time. We'll see how do we actually solve system of linear equations, which is our main target. If we know to solve given lengthy system of linear equations, we can form a regression model. That is only learning in today's session, right? So this is just some calculations. Determinant of a matrix. Again, I should not teach you dependent or independent. One way, no, AD minus BC is a dependency directly. Let's not waste our time. This many times we have seen this. Determinant. See, if the determinant is 0, it is a singular matrix. If it is not 0, it is non-singular matrix. If the determinant of the matrix is non-zero, it is non-singular. If it is 0, it is singular matrix. When another way, we talked about system of equations. When they are singular, when the statements are redundant, repeated, or contradictory. If you remember, when the statements or when the system of linear equations given to us are redundant, repeating, or contradictory, then they are singular. Okay, right. Rank of a matrix. This also we'll see how do we find out the rank of matrix. Mostly this is used rank with an example of imaging, image processing. We'll see how this is used. Compressing images. See, this is the original picture. Its rank is 200. If you reduce, if you same picture, if you see rank 1 of that particular image, it looks something like this. Rank 2, rank 5, 15, rank 15. Okay, not clear. 50. If you increase the rank, original rank, if you go, the picture is very clear. I hope you understood. Rank of a matrix. I'll talk little about not true, but autoencoder. I said autoencoder, you are trying to reduce the size of that without losing property. Right. Here, when you have a matrix with you, see, each image is a pixel. Each pixel is a matrix. So, matrix rank is 200. It means it is full of values. Okay. If the matrix rank is 1, it is very sparse values. Values are very, very less. Okay. So, in image processing, we need to know about the rank of the matrix. Sometimes we reduce the rank, we increase the rank, we find out the rank of the matrix. Okay, we'll see that. But generally, multiple definitions of rank of matrix. How to calculate, we'll again see when we solve everything. Determinant, rank, dependency, independency, everything can be known when you know how do you solve system of linear equations. System of linear equations. How do we solve this? Why we need to solve? If I can solve, I can find out the value of W matrix, W vector, and I can find the value of B. When I can find out these values, I can form a regression model which can be helpful for me in prediction. So before we go, let's take a short break of 10 minutes.